Welcome to the course in Software Development for Technical Applications. My name is Jonas Lindeman. I work daily at the LUNARC Supercomputer Center at Lund University. I have previously worked as structural mechanics. I teach a lot of programming for numerical scientific workflows and stuff like that. So this is how this course ties into structural mechanics. I will be recording these lectures. I will try to make them that you can attend from Zoom as well, but I would like to see you in person as well, because this is actually a premiere for me to teach on site. So it's in 2 years teaching online now. So it's kind of nice to have students in front of me. So what is this course about? So here we go. The idea is to give you an idea of how to implement the finite element code from start to finish. What I mean with that is implement the finite element code in code, of course, but also provide a user interface for a user to enter input to the program. And finally, also present the results, both numerically, but also graphically, visually to the user. And kind of learn how to put things together in well-defined chunks, modules that you can integrate to build this program. We will have lectures Mondays and Wednesdays. So today is 13 to 15, and then Wednesday is also the same time. I will record the lectures, but there's also an option to attend via Zoom. Just an overview of the lectures we were having. So today I will teach a bit about Python programming and the development environments that you can use for develop Python code. Matrix computing with Python. Could be that we go into this today, but otherwise it's the lecture on Wednesday. We'll teach CalFem for Python. So you probably, hopefully, used CalFem for MATLAB. And we have a similar version for Python that has the 90% of all the commands for MATLAB, so that you don't have to rewrite everything in Python. So we have CalFem for that. We're in lecture on user interfaces and object orientation, how to do scientific visualization in Python, also some perspective on Python and how this kind of programming can be used in different ways. There will also be a guest lecture from, not decided yet, but from one of the companies doing development of many of these tools for finite element design. And then we have exercises here in the computer rooms, Tuesdays and Thursdays. It will be good if you install the environment in your own laptop. So the computer room contains a lot of the software, but not all. So you have to install it locally in the machine because we couldn't get it installed in the computer labs. But you will work a lot at home with your accessor. So it's important that you have the environment, and it's free. So the course is designed around several assignments that you turn in. So there will be one worksheet per week, and there are 5 assignments that you have to turn in. And then we tie it together with a final report that is the final delivery, so to speak. It starts off easy with Python, and then we kind of build upon that. So every assignment builds upon the next. So it's important that you follow along and do all the assignments in turn, because they build upon each other. So you don't have to kind of make a new assignment. You work with the same code through the entire project. You can work individually or in groups of maximum 3 persons. And the examination is approved assignments, approved final report, and also participation in the final seminar. So the final seminar is where you present your work for the other students, but also you have the opportunity to get some feedback from other students as well. The course is available on Canvas. Is this link here? I hope that everybody has been able to get into Canvas. You don't know. Okay, we'll fix that. So I will try to, all information will go through Canvas as possible. So if you don't have your account, please contact me and I will make sure that you can get in. Literature, unfortunately, the main literature is in Swedish, but there is also a lot of English documentation and the worksheets, and you will have plenty of example source code to look at as well. So it's not only you will have to literature to kind of learn Python as well. Software we are going to use is Python, of course, and we will use a distribution called Anaconda, which is a commercial company that packages Python and all the packages you need for scientific computing. So you can compare it to MATLAB. It's the same environment. It's all the packages together. There are two ways of installing it. It's available on the Canvas site as well. We will also using something called GMSH for mesh generation and Carlson for Python. You install them together so that will also be available at the time you need it. So the course content. So you can decide, you have three base problems you can decide from. So you only have to implement one of them. Either is a two-dimensional plane stress application, or two-dimensional heat conduction, or two-dimensional groundwater flow. So you choose one of these. They are similar to implement in the complexity. And then you develop a user interface for that, and you develop visualization for that and package it together. You can develop this on PC, Mac, and also Linux if you want. And the development, as I said before, is divided into steps that you perform. So first you learn a bit about Python. Next week we'll go through CalFem and how that is implemented in Python, how you set up matrices, and then you continue and build an object-oriented model of that. I think I have a nice picture here of that as well. These numbers here are the assignment. So first we kind of make sure that we have a basic finite element model for your problem type in the first two assignments. Then we build a user interface or model here of our problem. And then we make a complete model that has a little bit more elements and complex geometry. And then we define our user interfaces in 4 and 5. Letting out of what you're in the end of the course here, what you will be implementing. So in this case, this is a two-dimensional stress solver. We have a solver here for solving the problem. We have a model here that describes the problem. We have the results here. We are using CalFem, which in turn uses GMesh. We have a visualization library called Matplotlib, which will visualize the results in. And we have Qt for implementing our user interface. So at the end, you will have done all these different objects here and implemented them in your program. The assignments can be found here on Readodocs. This link here, I think it's available also on Canvas. All worksheets are available. So if you want to work ahead, you can. There are some updates being done currently, so don't go too far in that. But I decided to make it all available so you can work. If you want to work ahead, you can do that. And they are available both in Swedish and English. So if you go into the site, you can switch between languages. And then I heard many times in this course, this question here, but I want to do it my way. And that is perfectly okay. As long as you do all the tasks and the functions that you have in your assignments, if they are implemented, you can basically implement them completely in your own way. You don't have to follow the assignments. As long as you do approximately the same amount of work for every week, you can design your program in your own way. There will also be extra worksheets if you want to expand on your project assignment. There are actually many students that wants to do this. They say, oh, I want to do this. And then I have some ideas how you can expand the code in different ways. So this summarizes. You don't have to follow the worksheets, but you must solve the basic tasks. You must provide a graphical user interface, a computational model for a problem, visualize the results according to the worksheets. You still need to have to submit one worksheet per week. So let's get into some of the why we have this course and why it's useful. So what does software development with technical systems mean? So I will show you some examples here of work that we have done before, but also now that describe some of these tasks here. So this is actually a visualization of the mirror to a telescope. And the adaptive control system for that mirror has a lot of actuators that control the mirror's surface. And we didn't have a visualization program to visualize this, so we developed our own visualization tool for this. So this is typically a task when you, for example, if you don't find you have your own code for computing something, but it doesn't, there's no clear way of visualizing things. Using this course here and the tools you will learn, you can develop your own code. So that's the idea. Using the program skills in Python, you can, for example, code in the most commercial codes that are available, they have Python built in. So using this tool, you can adapt those tools to create your own tool or adapt to existing tools. This is also a tool developed by a PhD student at Structural Mechanics called Sketchy Frame. It's currently not available in the App Store, but it was. And it was also a tool that, an interactive tool for visualizing structural behavior. So many of the concepts from this course is applied in the development of this software as well. Some of you have perhaps seen the ForcePad application. This is also an interactive tool for finite element analysis that you can do interactive. You can change the forces and you will update the stress image directly. It also uses several ideas from this course by dividing up user interface, model, and visualization in different blocks. We also have developed at Structural Mechanics the code called Hakon, which simulates the hardening of concrete. There is also the needs to implement, be able to assign the geometry, do the mesh generation, and then do the visualization of the results. Another bit more interesting example here is interactive program we developed for frame analysis where you can use your fingers to manipulate the model. So there is a special tool called Leap Motion that detects your fingers, and you can actually move around in the model using your own fingers and feel the structure. This is also a visualization tool for fiber materials that we developed. Many of these, for example, in insulation and diapers, we have fibrous materials. And to visualize those using the pure geometry can be hard because there are so many fibers. So we developed a tool for visualizing brown fibers using textures. Today we'll probably implement it using shaders and GPUs, but same concepts that we have in this course, we apply to this visualization as well. So let's see. We have, so this is the main page here. You have general information here about the course. I haven't published everything here yet, but the first one here is the required software packages that you can find how to install Anaconda. There is also a way of installing it in a more compact way here, which I also will make available today. Course materials available here. You have a lot of links here to different resources on the web. Here's also for the book here, there is all the online materials available on this site here. There's also exercise material for this book available. I will also add the course, so the lecture will be provided here. So there will be a link to the recording. Also links to the notebooks that I'm using for teaching. So as I said in my email I sent out today, you can follow along in most of my lectures because I'm using something called Jupyter Notebooks, which is a mix of text and Python coding. So you can actually do the exercises yourself during my lecture. And the links to that is here. So this is the Introduction to Python here. And if I open that one here, you should be into Python here. So this is the first lecture I will continue doing now. So let's see here. So if you click on that link in Canvas, you will get to this page as well. So let's start with Python. So Python is a relatively new language compared to many other languages. It was created by Guido van Rossum in 91. And the idea was to create a language that supported code readability. So I will show you that later what that means, but it means that the language itself forces you to write code in a very structured way. And you can also, there's a logical style to it that makes it's very hard to write unstructured code in Python because it forces you to indent code, for example. It also forces you to a certain structure of your code. Something that is a bit special for Python is that it's dynamically typed. That means that you can declare variables and they can change data type during the execution of the lifetime of your program. So variable A could be a number in the start of your code. It could be a string later on. So you can change types during the run. That doesn't mean that it's untyped like in language. Every type has very strong type. So it can either be an integer, a floating point, string, class, and so on. And it's also something that is very good with Python. It also supports multiple programming paradigms. So you can program structured procedural, so implementing your program as functions, divided up into modules. You can also work object-oriented, that is, create classes of objects that you assign, and every data type in Python is an object. So the programming language itself is very object-oriented, but it does it in a way that it's almost transparent. You can also do functional programming, which is a different task, which we'll not use in this course, but it's also supported. There are several versions of the language. So Python 2 was released in 2000. There was a major revision released in 2008, the 3.0 version. And it is not entirely backwards compatible, so we have to be aware of that. But fortunately, the latest version of the 2.0 track of Python is 2.7.18, and it has reached end of life. So you shouldn't be developing Python 2 code. When you start a new project, you should start with Python 3. And the latest version of 3 is 3.10.3. I think we'll be using 3.9 in this course because that is what the Anaconda default installation has. You can find the main Python code here, Python site here. So Python is a community open source language, and the main page is here. And here you can download a Python interpreter that only contains Python in its supported libraries. Anaconda contains Python, but also a lot of other libraries. So we are not going to use the original Python here. Anaconda Python distribution is found here. And yeah, you can download here your version is free and you don't have to pay for it. There are supported versions of that as well, but there's a free version of that. There is also an alternative called WinPython here, but we are going to use Anaconda Python in this course. So the language philosophy, I think, is really nice. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. And complex is better than complicated. And readability counts. So it's very focused on making things readable. There are certain cases where you can make it unreadable, but we should try to avoid that. But there's an interesting Wikipedia article as well on Python programming language. And actually, why it's called Python, because the founding father actually was very fond of an old comedy series called Monty Python. So it actually has a lot of references. If you read documentation, there is a lot of references to that series. So it comes from there. So program structures. So a Python program is usually written in a text file called source code file that contains rows of statements. And one thing that differs with Python and other languages is Python interpreters line by line. In C++, C, and Fortran, you compile your code to machine code. It reads the entire code and translates that to machine code and a standalone program. Python interpreter is always line by line. So it reads your text files and interprets line by line. That also makes it very dynamic. So you can write code interactive, just like you do with MATLAB. You can type a command, it executes, and you get the results directly. So every line is translated to machine code and executed all the time. Empty lines are ignored. The default extension on a text file is .py. So if you find a .py file, that is a Python source code file. Text files with statements are called source code files. I told you before. So very simple Python program can look something like this. If you have this one here, hash sign, that means that it's a comment. So then we can also see sometimes in Python code that you have this kind of strange things in the beginning. Those tell the Python environment what to do when it's to execute those. It's not mandatory. You can be ignored. You can write code directly if you want to. This one here, the second line here, is kind of important because it tells Python which kind of language you're writing. So if you're writing in Swedish language, you want to use you should put that statement in there because then it tells the interpreter that it should expect Swedish characters and international characters in the source code. So, and then you have the Python code here. So this is a very simple loop. You have a for statement here, and I want I to go from 0 to 9, and then I print them out here with a print statement print. And you can also see here, I will go through that later. There's a colon here. That means that this statement here wants to have a second statement that it should repeat. And this tells the compiler that the next statement here that is indented here will be part of the for loop. So the colon here requires you to indent the code here to tell the Python interpreter that the print statement belongs to the for loop. So always when there is a colon, you need to indent the next part of the code. So I can run this code here and see what happens. And you can see here that it loops from 0 here to 8. This is something that is for historical reasons, but it goes from 0 up until but not including 9. So you can see here 0 to 8. And the print statement prints 1 every row.
You can use end after.
No. So this is different from MATLAB. But you can, as you see, the thing is that with this interactive lecture series, I can change this here to 10, and then I can run it again. And you see it goes from 0 to 9. So MATLAB doesn't have this, you don't have to structure your code like this in MATLAB. You can just write code at the end and determines where the blocks are. In Python, the blocks of code are indented. Can be a bit hard to get used to, and also sometimes in your editor, it can be hard to configure them so that you have a consistent indentation. So if you have a kind of jagged indentation, Python doesn't like it at all. So you need to have the same number of characters indented all the time. Built-in functions. A lot of the cool things about Python is that it has a lot of built-in functions that you can use for a lot of things. And a function is described with you have a name of the function here, and then there's a parenthesis, and then you have a list of parameters that goes into the function, and then you end with a parenthesis. It's similar to MATLAB, except that you don't have to. It's very similar. And also many of the functions in Python is you can also skip having any parameters, and you do like this. But you need to have a parenthesis pair, otherwise it will not work. So this indicates that this is a function, but you don't provide any parameters. Functions in Python can also have return values. You assign return values using the equal sign here. So y equals the absolute of -4. That will assign this variable the sort of value evaluated from the function. Something also that's very similar to what you can do in MATLAB is that you can have multiple return values from the function. So in this case here, I do fractional division here, and then I have a quotation and a ratio here, and then print both of them. So you can have Q comma R equals. This function here would assign both of these variables values. Storing and referencing data. One of the strong parts of Python is that you can work with data stored in different ways. And also the variable name that you give to something is not the data itself. So a variable can describe as a pointer to data in memory. So a variable can actually point to different things during the lifetime of a program. So it can be like you give your coat in a restaurant. You get a ticket, and the variable name is the ticket to that data in memory. And that is something keep in mind when you work with Python, because sometimes you can have variables point to the same thing, and that is important to kind of remember that the variable name is just a reference to data in memory. So here I have an example. I assign A equals to 1, B equals to 15. If you assign variables, that these will be integer data types by default. So if you don't provide a decimal point, it will be an integer. If you provide decimal points, Python will interpret that as floating point values all the time. Strings, you have quotation marks around them. You can have different quotation marks, but we'll get back to that as well. You can create lists. You just do a bracket here, and then you list the values in the list. A list can have multiple data types. You can have floating point integers. You can have strings. You can have other lists inside a list. That is one of the most flexible data types in Python. And you can see here that I had A here before, and now I assign it to string. So now the floating point value, the integer value I assigned to A is now freed up because there is no references to it. And I assign A now points to a string. And that you can also change the data type during the lifetime of the program, which is quite powerful, but also a bit confusing sometimes. Can lead to some errors as well. Naming of variables. You can only have letters from the English alphabet in the variable names. You can have numbers. You can have you can't have a special character except for underscores. Variables can't start with a number, and variables are case sensitive. That means that an uppercase in the beginning of a variable with the same name with a lowercase is different variables. So, for example, allowed variable names are first name, because here it starts with a character and it has an underscore, which is okay. Last name also okay. Number I2 is also okay. This is not okay because we can't start with a number. Arrow is also not okay because you can't have you only have to have variables with the characters from English alphabet. So that's also not allowed. You can have strings with international characters, but variable names must be in English. Yeah, now I come to this point with try to explain this with variables and how they're referenced. So variables in Python are references to the underlying data. So when you assign a variable, first the memory is allocated for the integer. And then a reference to that variable is created, the variable. And now the variable refers to the memory for that value in memory. If we look at this here, I assign A equals 42, B equals 84. So now that these are, what happens in memory now is that you have the situation like this. A points to memory location 42, B points to memory location 84, containing 84. We have two memory locations now. So what happens now if we do like this? A equals to B. That means that A reference now points to the storage location of 84. And the storage location 42, there is nothing pointing to it. And Python, in that case, will, behind the scenes, erase that memory. So it will be kind of, it's called garbage collected, which will be removed. But you can see here that A and B points to the same memory location. So changing B will also change A. Will change the kind of value of A if you look at it. So let's see here if we run this. You can see if I print A, it will point to A, also say 84, and B will also say 84. Most of the times you don't have to think too much about this, but it's good to have that in memory when you're programming. If you get strange result, think about this. Are we referring to the same thing? It becomes important when you're working with lists, because you can have multiple variables pointing to the same list, and you modify the list, and then all of a sudden the list is modified without you knowing it, because some other part of the code modified the list and they're referring to the same list. And then you can have a situation here. So for example, if I assign A equals to 21 again, now you see here A doesn't point to that anymore, it points to new storage location. And now that goes away. You can check the actual, what it points to using a function called ID. So ID will return a unique identifier for a variable reference. In essence, that is basically the memory location you can get back. So if we run this here, first here, I assign them again, and then these two should be different. And then if you look at this one here, you should have the same ID of both of them. And then you should create a new ID for A here. So let's run and see what happens. Let's go up here. So we can see here that we have two different IDs here. Then I do A equals to B, and the IDs are the same again. And we do A equals 21, and we have two different again, but the B is still pointing to the same memory location here. So ID is just a kind of a way of checking that your reasoning is okay. So it's usually not something that I use a lot in my code, but it's there. It's a built-in function. So data types. As I said, you don't have to explicitly define a data type in Python. So integers, you just assign, and then you don't use a decimal point. That will be an integer. If you assign 42.0, it will be a floating point variable. And you can also see when you print. So if you print a variable using the print statements or just doing return here, you can see here, if there is no decimal point, it's an integer. And Python will also print with decimal points if the data type is a floating point variable as well. Operators, and they're evaluated in this order. So exponentiation, so raise to the power of. You can have minus and plus before variable to negate them. You have multiplication, division, floor, and modulus. So modulus is percent sign. Floor is double sign here. You have addition, subtraction, comparisons, Boolean not, and an or. These are the built-in operators. This is just an example here. So this shows you how to use a Python interpreter interactively. So by default, it's a very complicated or very competent calculator. So in this case here, just adding two numbers together will return 4. And then you have a more complex expression. This is also important to know that if you are using Python 2, the results of different operations can differ, especially if it comes down to integer division. So in Python 3, dividing two integer values, if it's it will return a floating point. And in Python 2, if you return the integer division. But I don't think you will use Python 2 a lot in commercial software. Most of them have moved to Python 3. Flags and Boolean variables. So you also have a data type in Python that can store either true or false. It's called a Boolean variable. And a Boolean variable is created by assigning a variable name either true with an uppercase T or false with an uppercase F. Then it will be a Boolean variable. So if you print a Boolean variable, it will print true. And if you print, see also the value will be either true or false. Lists is the next one that is one of the most used. I would say I will use lists most of my coding because it's so easy to use. Great. So an empty list is created by values equals to empty brackets. It's similar to what you do in MATLAB, but you need to specify items in the list using a comma here. In this case, I just list my values in the list, and you can have both integers here. If there's a string, you can have floating points. So it can store any data type, and also other lists as well. And it prints it out in a way that you can actually take this one and assign another list. The same kind of prints it in the same way. One thing you should not use lists to is actually numerical computing, because the list is a flexible data type in that it can handle multiple different data types, but that also makes it a bit complicated or inefficient for large sets of numerical values. So we will come to that later on for matrix computing, because you can store a nested list and create kind of a similar structure like an array, implemented with lists, but it's not recommended. But for other stuff in your code, except for arrays and matrices, I think lists is very nice data type to use. You can get to different values in the list by providing a number, an index to the list. And all indexes by default start with 0. So the first item is 0. In this case, is the third value in the list, third item in the list here. So 0, 1, 2. You can also change value in the list. Very simple. You values, and you have an index here 4, and then you just assign what you want to assign to that position in the list, and it will update and modify that. So now you see it's changed the string here to 4. Just there. There's other interesting things here that you can do. If you provide negative indexes to a list, it will return you the last element of the list. So this is a very quick way of, if you want the last item of the list, you don't have to query a list for a length and put that into the index. You can just do -1. And if you want the third last element, you can do -3. Then it will wrap around and go back to the front, or go to the end of the list and go back the number of positions with specifying the index. Quite nice feature. That is also available later when you are using arrays. You can do minus index in arrays as well. So lists and variable references. So as I said before, variables are references to data, to storage of data in memory. So if you have a list values here, it has a storage associated to it. And inside that storage, you have references to other storage in memory. So in our list here, we have the first item here is a reference to storage element 1. This one has a 3 and so on. So the list in itself is points to data in memory. So everything is references. And to illustrate this, I have a list here, values, and I assign B values 4. So 0, 1, 2, 3, 4. So this is this one here. So B should be assigned this one here. Then we print out ID of B, and we also print out ID of values 4. Let's see what happens. Interesting, but they point to the same referencing memory. So B here now has a reference to the same storage location as this one in the list. So the situation in memory is like this. You have the values here, that points to these references here. You have B now that points to the same memory location as here. So if you assign a different value to this list here, B will also change. Yeah. But in most cases, it worked like you intuitively want it to work. So you don't have to think too much about this. Index notation. So you can reference lists in different ways as well. So you can have, if you want to extract values here, going from 1 up but not including 3, you can do 1:3. You can do 1 colon up until the last, but not including the last element. You can have values starting from 3 going up until the end. Just a colon here will have all elements. Colon -2 to up until not including -2 here. So similar what you do in MATLAB. You can also do ranges from -3 going to up here. So we just run this and see what happens. Here you get different ranges. All of them return sublists that you can use later on, but all of them reference the same memory location. So keep that in mind. Sizes of lists, very common operation. You read something in and you pass it the list along, and your function needs to figure out how many items are there in the list. Python has a single command for doing this, and it's used in almost every data type that you have number of items. You can use len function. So len values will return the number of items in values. And that also we will see later on, then can be used for other data types as well. So if we print out this one, we print out 7. Adding value to this. So it's not often that you have the situation that you just assign a list in the source code. Often you have things in a data file on disk that you want to read in, and then you want to process that and add things to that list. Then you need to be able to add things to the list. There's a method here called append. But I said it before, every data type or variable is an object in Python. So values here is a list object, and the list object has several verbs or methods that you can call on that list to modify it. And one of them is .append. So in this case, I add 42 to the end of the list. So now there is 42 at the end. There is also a method called insert, that where you can insert a position before a certain position. So in this case, I insert here, squeeze here after position 1. That will move all the things to the right. You can remove values from the list as well using the remove method. In this case, it will search the list and remove squeeze from the list. And you can see here, I printed it before remove and after remove. See what happens. It's also, finally, you can use the delete function to delete a certain element index. So if you do, this is also a generic common function that can be used on multiple data types. So in this case, delete value 0. It will delete the value at position 0. Here you can see you have 1 here at first position, and after the delete, so. I think we will take 15-minute breaks now and continue after that. Okay, so we continue. So you can also delete using subranges as well. So in this case, you can use delete, and then you specify what range you want to delete values. So in this case, I want to delete everything from position 3 and forward. So here you can see here, this is the before, 0, 1, 2, 3, and then it deletes everything after that. So then you have left is 0, 1, and 2. You can also use a list as a stack. That means that data is added and deleted from the end of the list. And there is a special method called pop that will pop the value from the end of the list and return it back. So this will pop things from the list. So pop will return, V here will be 4, and then 4 is removed from the list. So a stack in Python is essentially a list as well. Lists can be cleared as well. There are 2 ways of doing it. So first you can just assign an empty list, and then the previous list will be garbage collected. But in this case, you can, if you have other references to this list, it's still possible that the items in the list are still referenced and still in the memory. And in that case, for example, here, B equals A here. So now I do A equals 0. You can see here that B will still contain all the values in A here. So even if I do A equals to empty bracket, it only means that A points to an empty list. The list in memory is still there if there is a reference to it. If you really want to remove the things inside a list, you can use the clear method. So the clear method will actually remove the items in the list. So in this case, I have the same situation here. I have a A with a list, B points to the list of A, and then I do A clear. And if I print B, the item should be gone from that list as well. So as suspected here, I get an empty bracket there as well. So clear will actually remove the items from the list, clear them. Another nice thing is that you can have nested lists. So a list can contain other lists and indefinite depth of that as well. So in this case, I have A here, 1, 2, and then I have a list with 3, 4, 5, 6. And if I access item number 2 here, so 0, 1, and 2, I should return and get back a list. So that seems to be okay. So 3, 4, that is the list here in the middle. You can also, if you want to access an element inside that sublist, you can add another bracket index operator here. So in this case, I can do item 2, that is the list, and I want the 0 element of that item, and then I want item number 2 in the main list, and then sub index 1. So if I run this, it should be 3 and 4 coming out of that, and that is what it is. You can also create two-dimensional data structures in simple ways here. So in this case here, I have a spreadsheet I call first initialize with empty list. And then I want several rows of items in this spreadsheet. And there is a nice, interesting feature that you can use here. So if you have create a list with a single item here, and then you multiply by 10, this will actually repeat that element and create a list with 10 items in it. So 0, a list with a 0 in it, times 10 will create a list with 10 items in it. So let's see here if I run this. You can see here I have a list here. Every row here is another list here with zeros in it. And you can see here, if you do len spreadsheet, len will only return the outer elements of the outer list. So in this case, it will be 4. And if I want to access row 0, element number 5 here, that is 1, 2, 0, 1, 2, 3, 4, 5. Yeah, of course that is 0, but this is where you can access that. But as I said before, if you need to do numerical computing, we should go to NumPy, which I come back to in a later lecture. But this is a way to create two-dimensional data structures. Yeah, this is also something to note again with this reference in here. So in this case here, I have B equals to 3, 4 as a list. I create a list A here, which I add B into. And then I assign B0 minus 1. And we look at B and A and see what they contain. So now you can see here that I modified B. And you can see that B here is minus 1. But you also see that A, the sublist of A also has minus 1 because they reference the same data storage in memory. So you can describe it in this picture here that you have 3, 4, that is the B list, and it's also referenced to by the A list here. And if you don't want that, if you don't want this, how this works, there is a way of actually making a copy of the data. And of course, it's called copy. So in this case here, if I want to add B to A, but I don't want it to be connected or referenced to each other, I can just do a B copy. That will create a new list and insert that into A. And now if I do B0 equals to minus 1, it shouldn't affect the list I added to A. So you can see here, minus 1, that is the modified B, and then 3, 4 is the old B. But that is a copy now. So now they are disconnected. So, and this situation here. So I have B copy, makes another copy, and the reference in the list points to this copy. There's another data structure called tuples. And it's a special form of list. It's ordered, and tuples can't be changed. So they are immutable. And instead of square brackets, they have parentheses around them. And the idea, the reason for having tuples is in certain situations, they are faster because they can't be changed. They don't have so much overhead and can be passed around faster. So, for example, if you get many functions return a tuple, that's a read-only list of parameters that you can assign to other variables. So it's not like the variables themselves are immutable. It's just the list itself is immutable. So here I created a tuple, and basically the same rules apply for tuples as lists. And you can print out items. You use brackets to access them. However, Python doesn't like it when you assign something to a tuple. So in this case, I tried to assign 0 item to 42. And then it says a tuple object does not support item assign because it's immutable. You can't change a tuple. You can assign the values of a tuple to other variables, but the tuple itself is read-only. This is just a theoretical example that you can actually add things to a tuple. But what actually happens is it creates a new tuple that is immutable. So yeah. It's academic. Another important data type that is much used in programming is the string data type. So string stores a sequence of letters. And there are one of the big features, string handling in Python is actually something that is one of the big features of Python that makes it also very flexible. And strings are also immutable. So when you create a string, you can't change that string. That sounds kind of like a limitation, but it's not, because it's so easy to create new strings. So if you want to create a new string combining 2 of them, yeah, you just create a new string. It's still immutable, but you can combine and create a new string of 2 immutable variables. So it's not that limitation. It also makes string handling much faster because it doesn't have to support modifying single text inside a string. So you can create strings in different ways. You can choose the delimiters of strings, either be double quotes or single quotes. So in this case here, these are equivalent statements. They both produce a string. The strings are identical. But you can combine these here. So sometimes if you want to print double quotes, have double quotes in a string, you can use single quotes to delimit the string. So in this case here, I want to have a single quote inside and have double quotes outside. And you see here now I have a single quote inside a string here. And then I can use same thing here. I want to have double quotes inside a string here. I can have a single quote, double quote, single quote. And you see here you can have double quotes inside a string. Yes. Then you can have, so all strings in Python are interpreted. So you can use certain control characters inside a string to achieve things. For example, if you want to have a quote, single quote inside a double quote, a single quote, a string, you can do that by adding a backslash character before the character. So this will make sure that you get a single quote even if you have a single quote a string. Also backslash, because that is a separate meaning in strings, you need to be able to add a backslash. So you do 2 backslashes, then you get a single backslash. Same thing here, if you have a double quoted string and you want to have a double quote inside a string, you do backslash double quote. You can have a new line. For example, if you want to print something that have multiple lines, you can have backslash n for a new line. There is also backslash t to get a tab inside a string. So in this case here, I have a string. There's a backslash n here. So if I print that string, it will go over 2 lines. So it will divide it into 2 lines. Sometimes you don't want Python don't care about the control characters inside the string. I want to actually have a string with control characters in it. I can prefix it with an R that stands for raw. That is a raw string. And then it will actually ignore any control characters that I have inside the string and print it out. So in this case here, the first one I have a prefix R, and then it will actually print exactly the contents, compared to this one here, which will interpret this N here. So in this case, you can see here, this is the string that is not interpreted, and this one, the control characters are interpreted. There is another string version here. It's called triple quoted string or similar triple. This is a string where you have 3 quote characters. It could be either double quotes or single quotes, but there are 3 characters in front of them. And then the string starts. And this string will interpret everything that starts with a string. So if you do a return character in the source code, that will also be included in the string. And then basically you can create a template of how a structured text will look like. And you end with a triple string. And it will be exactly as it is formatted in the source code. So if I run this one here, it will print over 3 lines like that. Length of strings. So same thing here. Now you get this method again, len, that you can use on any data type. So if you do len on the string, you will get the number of characters of that string. So if we run this one, you get a string of 18, a string of 25, which should correspond to the length of this here. And you see also here, I use international characters here, ORL. And then you need to do this UTF-8 in the beginning. You can create new strings by concatenating using the plus operator. So in this case here, S3 will be created from S1 plus S2. So here you can see it's not a big issue to have the limitation of read-only. Repeating strings, you can use as we did with the list, the multiply operator. If you multiply a string with an integer, it will repeat that string. So for example, if I want to do an underline of this text here, I can do S2 equals to underline character times the length of S1. It will create a string just filled with dashes, the same length as the string. So if I print this one here, you will get a dashed line here, the same length as the previous string here. Splitting strings. This is, I don't know how many times I'm using this in many applications. So suppose you have read something from a file and you want to divide it up depending on the spaces or some other delimiter. You can use the split function on the string. So split is a method of the string object. And if you just do split here, it will split on spaces. So now we get a list of words. So in one single statement, I have a list of all the words in the string. You can also have, for example, if you read numerical data from a file, you have a string with comma delimiters. And I want to split them by commas. I can do that as well. I add a parameter here with a comma. And then I can just, if I run this, it's a bit, yeah, there are some spaces here, but basically it divides it up into chunks divided by the delimiters. You can also go the other way around. So if you have a list of strings, you can go to a string and you can use a method called join. The syntax of this command is a bit odd. So if I want to join the list here and combine them together with spaces in between them, yeah, I take a space string here, this one here, and put join, and then the list I want to create a string from. That will take the list and put that space string between all the items. I can do the same thing. I want comma separated string, I use a comma here. And if I want to have a string without spaces, I can just do an empty string here, which is 2 quotes like this. So if I run this, you can see the first one, we just put spaces between the words in the list. Here I put commas between the words in the list. And here I just put no spaces in between. So just compress it to a single string without any spaces in it. I can search strings. Python has a special operator called in, which you can use to query if things are inside the data structure. So in this case here, I have S here, and I can check here, is there a word called vocalia in the string? And then it should return true. Yes, so this string is inside this string. So this is a quick way of checking for a string, substring in a string. Just ask it, is it in S? It's almost like natural language in this sense. There's also a way of using, there's a method called find on the string. And find will return the position in the string of the word that you're searching for, the first position. So in this case, search find far. It should find this one here. Then you can also search, tell it a starting point here. So I use the position from the last search here with 1. So I start one step further and continue searching. And then it returns 4, that's correct. And then the next far is on 41. And if it doesn't find anything, it returns -1. So this was the way of searching. Before in, you needed to always use find. But in can always solve one problem, is finding the first word that it fulfills. Sometimes it's also very good to be able to strip off unnecessary space in the beginning and space after a string. So this is a very common situation when you read from files, that you have extra space here and you have extra space at the end. And there is a command called strip that will strip away those extra spaces from left and right. So if we run this, you can see here that this is the original string, and this is the string after we call strip. And then if you don't want to strip one side but the other side, there is 2 versions of this method called rstrip and lstrip. So rstrip will strip from the right side and lstrip from the left side. So here you can see I have right spacing here. I don't want that. And rstrip will remove the right side. Same thing if I have on the left side, I can do lstrip, and it removes the spacing in the beginning, but not after the string. Sometimes you also want to query the data type of an actual variable, because you don't have to explicitly define the data type in Python. So sometimes you want to query actually what data type it is. There is a type command here, function that will return the data type of a function. And you can see here that one is int, float, bool, and string. So now we come to the second most powerful data type. So we went into lists, and now we go into dictionary. So lists, you have a numeric index to access the data in the list. Sometimes you need to access data structures using a key that is not an integer. And there is a special data type in Python called dictionary that can store key value pairs. So everything you store in a dictionary has a key. It could be a phone number, it could be a name, and a value associated with that key. And it's created almost the same as a list, but instead of using square brackets, you use curly brackets. So this creates an empty dictionary. And the nice thing with dictionaries is that you can actually search them quite fast. So if you want to determine if a key is inside a dictionary, you can use the in statement, and it will much faster search through this data structure than using a list. And you can see here, if you want to pre-fill a dictionary, you need to kind of specify things in pairs. So in this case, the first pair I add here is Petra and colon, and then I have a phone number here, David and the phone number, Ulla and the phone number. So you always add them in pairs. So this dictionary contains 3 keys, and each key has a value attached to it. The keys can be any data type. The values can be any data type. So you can have list or dictionary containing references to other dictionaries, other lists. You can mix and match in any way you want. So in this case, I okay, now. So if I print it out, you can see here that it prints it out in the same way. So it prints key, value, key, value, key, value. And you can access the values in a dictionary by similar syntax as the list. But instead of specifying index, you specify the key. So in this case, values David here will return the value associated with the key David. Same thing with Petra here. So now you see here it returns those keys or values associated with those keys. Assigning values to a key or creating new keys, it's very simple. You do values and then you give your key name and assign a value. If there already is a key, it will be replaced and a new value assigned. So in this case, it will be a new value here. So now I have Peter as well here as a new item in the dictionary. And now we come to the things that really makes the dictionary shine. So I have a index here with keys and values, and I can actually quickly search them and they return true. So Petra in index, if that is Petra, the key is in the index, it will return true. If it's not, Busse is not in the index, it will return false. And that operation is much quicker than searching linearly in a list. So this is a very fast operation to search lists, to search dictionaries. If you want to know the number of elements in a dictionary, you use the same function as before, len. So you can see here that a lot of the functionality in Python is the same for every data type. Adding values is very similar to what you do with lists. So just create a new key associated value. If there is already a key, it will be overwritten. And as I said before, it's a very flexible data type. In this case here, I have created a configuration for a program. I have divided it up into sections. I have general, constant, items. And inside general, I also have a dictionary username, temp path, constants, items. And then I can do stuff like this. So I can do print config general username. So that will go first for the first key. And there's a dictionary under that key called username. And then I can nested dictionaries. And you can also see that I can have lists inside a dictionary as well. So before inventing any complicated data structure yourself, look and see if you can use a dictionary combined with lists to create your own data types or your data structures. And they are quite efficiently implemented, so it's quite fast to search them and find items in them. There are some assignments here. I will skip them now. You can do them on your own. So now we have just looked at data types. So now we want to work with data types. We want to be able to loop. We want to be able to use if statements and logic. So the first thing we have to kind of learn in Python is the code blocks, what those are. So for every statement that you need to repeat something, you want to test something or check something, you have to use a code block. And code blocks in Python starts with a colon. So in this case, I have a for loop here. I have the colon here. And the colon tells Python, next line will be a code block. And the code block is always indented. So to tell Python that this print statement here belongs to the for statement, it has to be indented here. Usually by 4 characters. I use 4 characters for most of my things. Important is that you use the same number of characters all the time. Otherwise, Python will be confused. This print statement does not belong to the for statement. Because it's outside here. Should be okay. I will fix that. But if I run this, it will print out this one here, and this does not belong to the code block. If I move this in here, like this, now the print statement print A will also belong to the code block and will also be repeated. So you see it will 0A, 1A, B. So we can kind of repeat this statement here. Okay, we'll move this here. So everything that is part of code block must have the same indentation level. So continuing on with the loops. So we've shown before you can loop with using the for I in range. This will loop from 0 to 9. So 10 will not be included. So it's up until, but not including 10. You can have, so this will be like this. You can have a starting point as well in the range declaration here. So 5 means we start from 5, go up until 10. So 5, 6, 7, 8, 9, 10. I can have a step length as well. So that you can have 3 parameters. First is the starting point, the end criteria, and then we have the step lengths. Like this. So usually when you iterate in Python, you almost never iterate directly using index variables, because you can iterate over a list without having a loop variable or having an index variable. So in this case, I have a list here. I want to loop over every value in the list. I can do for value in values. So value will be the first iteration will be the first item in the list, next iteration with the next item, and so on. So you don't have to kind of index with numbers here. Of course, you can do that as well. So you can do, for example, for range lane A, then you can iterate over a list item. For example, if you have 2 lists that you want to iterate over, you need to kind of have the index in here. So then I get I here, and then I can use I here to index the different lists here. You can also iterate. So if you want to need to have a number for each iteration, you can actually use a special function called enumerate. So then it will actually create a pair here. So you have I will be 0 in the first iteration, 1, 2, 3, and 4, and then value will assign the value to the list here. So that can be useful sometimes if you want to access values from another list without having to have loop with ranges and stuff like that. You can use this instead. It's kind of, so there is almost a loop construct for every taste of looping you want. You can also loop over multiple lists at the same time. I will show you that when we come back to CalFem later on. I think this is what we will do when we loop over the element topology, for example. So in this case, I want to loop. So I have 2 lists here, X positions and Y positions. I want to loop over those and work with X and Y coordinates. Then I can do zip X position, Y position. Then it will extract a pair from these lists all the time. So the first iteration will be 50, 50, next one will be 130, 70, 200, 220, and so on. And if you look at the internal structure, if you do zip X plus Y, what it actually means is that it actually zips them together and combines them to a list of pairs. So this is what zip does conceptually. You can, if you print the zip, it will not print out, it will just print, this is a data structure. So the reason I do this is that it will convert it to a list to illustrate how the structure is. You can also iterate over a nested list. So for example, if you want to iterate first item here and then loop over the internal list here, you can do a nested list like this. And you can see here, the first code block is this one here. So I indent this for statement once. And the code block for this internal is indented once again here. So the print statement here belongs to the internal loop statement here. And this will loop this internal loop statement over points here. Like that. So now it goes from 50, 50, 130, 70, and so on through a list. The dictionary is a bit different. You can do also here different ways. You can iterate over key value pairs. So in this case here, there is a method called items that will return you a key value pairs. And then you can, in the for loop, you have key and value that you can use to access the key and the value of every item in the dictionary. It's also possible to just iterate over the keys. So there is also a method called keys that will return you a list of all the keys in the dictionary, and then you can loop over that list. I can see about this one here. All of these will have the same results, basically. You can also, if you're only interested in the values, you can use the values method of the dictionary. Then you have a list of all the values, and you can iterate over those. So you can do, there's very many things that are doing the same thing in Python. But I think it's also because you need to do different things depending on the situation. You can also iterate, there's a while statement that you can iterate over. So while a certain criteria, it will continue looping until that while statement is true or false. It will exit that loop. So in this case here, it will be just an iteration here, and it will stop when the error is at a certain position here. And finally, we have the conditional statement. So if you want to test for a certain condition, you can do if, and then you have a condition. And if that is true, the code block is executed. So the if statement, you see there is a colon here. That means that you have a code block here that is executed if that condition is true. And then you also have a version of that with else. So if this condition is true, this is executed, otherwise this code block is executed. You can have several statements here. So if, elif, so that will, if that is true, this will be executed. If this is true, this is executed. And if none of the above is true, else this code block is executed. And of course, you can have nested if statements. So for example, if this is false, it will check this if statement here that belongs to this code block here, which is indented. So also, if you have a loop, you can control the loop iteration with two statements. There is a break statement that will exit the loop. There is a continue statement that will continue to the next iteration. So for example, here, if I equals to 10, if I do break, this loop will terminate and continue after here. If I do 5, it continues, this will jump to the next loop iteration. So running this, it should never go to until more than 10. And in this case, when it's 5, it goes to the next iteration. So this statement is never executed. So I will stop here and just show you the development environment that you will be using as well. I can make it stay here. Okay. So if you install, let's stop here. If you install Anaconda, there will be there is a Spider development environment which you can use to run your code. So start here. It will create an untitled.py file. I can write print like this. I can save my file here. Just put my test.py. Now you can see it automatically fills in here the coding standard here to make sure that you can use international characters. The first part here is a document doc string is called. So that is something that tells some information about this code, source code file. So these triple quotes can be used as comments as well. But then this is my first statement here. I can press run here, and it should print something out here on the console here. Hopefully. Hello world here. So for your first assignments, you can use only this spider environment. You can also open a command prompt. There's an Anaconda prompt. Should be in the start menu somewhere. So this is I can type Python here. Okay, my computer is wrong. I think if you start Anaconda, you should be able to type Python here, and then you can let's see here. I think I was okay. That's one. This is what you should get with Anaconda, and then you can do type Python here. That will enter you into interactive Python session. So if you type a equals to 1, you can do print a like this. B equals to 2. So you can use that to go. If you want to exit from this one, you can type Control D. Oh, sorry, Control C to exit out, and then you're back again. You can also do Python. And then you specify your source code file. I think it was on my desktop here. So you can execute your Python like this. If you want to do a notebook like I was doing in my lecture, there is an instructional video in Canvas where you can how to create a notebook. I will go through that in a later section here. So see you tomorrow morning. I think it was nice. And then we have a lecture on Wednesday. Yeah. The next, yeah. So. Sorry?
Tomorrow morning only an exercise session about basic Python.
Yeah, so the first assignment basically we will use that. So it's not, you don't have to